Okay, hello. So this task is some root to leaf numbers. Wait a second. Okay. So I solved this task before. Um, Let me just remove whatever I have here to solve it again and check if I be able to do that fast. So let me read the problem statement and I'll try solving it. Okay. So my idea is to have the DFS and accumulate the number in a kind of variable and then have a global sum. Whenever I reach the leaf, I will add whatever number I have accumulated to a global sum, and then in the end I'll return the output in this case. So there initially I'm gonna have this int sum equal new int, and then let's say 0, and I have private void DFS, and then 3 node, and then int number, and then accumulator, like global sum. And then what I'm gonna do, if node equals null, I'm gonna add. So let me just keep it as of now. So if node left not equal null, I'll do the following: DFS node dot left, and then num multiplied by 10 plus node dot value. If node left is equal null and node right is equal null, then I'm gonna return node value. Return num multiplied by 10 plus node value. Oh no, not return. I need to add that to the global maximum, to the global sum. Sum 0 plus equal num, like this. If node dot right not equal null, gonna do DFS node dot right, and then num multiplied by 10 plus node dot value. And then I need also to pass the sum here and sum here. And to call it, I'm gonna call it for the root, and then I'll pass 0, and then I'll pass the sum and return sum 0. So there are many ifs there, and again I need to account for the null value. So if root not equal null, then I'm gonna return this. I'm gonna call DFS, otherwise I guess I'm gonna stay 0. So they don't mention those. The trees, number of nodes in a range from 1 to 1000 means that there should be like at least one root. There won't be situation when I have like zero nodes and then null is passed to the some numbers. Um, I'm thinking about how I can simplify this code in order to avoid this node left equals not equals null. Okay, I also need to return here. Yeah, I guess if I do like this and submit it, should be okay. Let me experiment a little bit to make it more beautiful. If I'm gonna call DFS, like if node null, if node equal null, I'm just gonna return. If node left equal null and node right equal null, it means that we are at the leaf. So I gonna add result with some 0 and return. Otherwise I will do DFS, node left, node right. This will help me eliminate that check at the top. Something like this. Okay, let's check it. Okay, another question, so let me check the timing. Am I recording anything? So it's 8 minutes. So if I gonna save the sum in the variable, will it improve? Mhm. Not really. Yeah, I wonder if I do BFS here. So let's say I do private void BFS, and then no, not void int BFS, and then 3 node root, and then that's it. And if I do the following, I'm gonna add the element q 3 node equals q equals new linked list, and then I'll do the q over root. Okay, if let's say we have int sum equals 0, if root not equal null, and then I'll q over root, and then I'm gonna do q over root, and then while q is empty and while it's not empty, I'm gonna do int level equals q dot size, and then for int I equals 0, I less than l, I plus plus, and then I'll do q dot poll poll, and then 3 node, and then node equals q dot poll, and then I'll do int a little bit higher, int multiplier. So every time yeah, every time I need to multiply by 10. So sum multiply by 10, and then node poll, and then sum plus equal node wow, and then if node dot left not equal null, I'll do not really, because they're gonna be different lengths. And I need to push that one that end earlier. Okay, how to do BFS here? So the problem here is that, like, if I have a different size um, of the veins, then if I go like the vein size 3, I need to maximum multiply by whatever, like, gonna be 3 digits in the number. If I have vein length 5, I'm gonna have like 5 digits in the number. I have right now idea to have this carry and their digits. Let's say we have like something like this. Int and int the same, carry new int 10. By digit, okay, we don't need carry. By digits, it's gonna be fine. So, and here I'm gonna have int index equals 0, and then every time I'm gonna finish the traversing the query queue by level, I'm gonna increment the index. And then here I'm gonna do not all, not left, not equal null, by digit I plus equal node dot value. And then not left, not equal null. I'm gonna do the following. Q dot offer not left, and then if not dot right not equal null, I'll do Q dot offer not dot right, and then in the end I'm gonna do the following. Int result equal 0 for int I equal 0, I less than n by digits length. I'm gonna do I plus plus, and then result equals result multiplied by 10 plus by digit. I don't know if it's gonna work. Return result. So let's check the null root node. So the root gonna be null. The queue, you know, won't offer that int okay 10 index 0. Queue is already empty. Result 0. Okay. BFS. Mm. Ah, okay. So like it's kind of I should reverse the order. Yeah. Where is it? So the first one is actually the first node is actually the major one. Yes. So 1 2 is 12. But in my case, I was doing like I flipped the order. So for every digit here, I have for the level, let's say for the first level starting from 0. So for the level 9 and 0 here, for the 9 I'm gonna have Yeah, for the 9, so 0 here is should be affect like the the ones, and the 9 here should affect like tens, and here 1 should affect ones, and 4 should affect both like hundreds if you go like to the left branch, and ones if you go to the right branch, like tens, yeah, if you go to the right branch. Okay, let me check the solutions. Do they have, or editorial, do they have BFS? Oh, like, let's check what I was submitting before. So this one is not that efficient, but yeah, it looks like DFS. This one look like DFS. Let's check the earlier one, or the later one, or like the fresh one. It's also DFS. Okay, whatever. Let's check them by memory here. So let's put the. Oh wow, that was nice. This was nice, but it's still DFS. I wanna see BFS. Hmm. Hmm. I wonder if that still holds, that solution. Let's check. Let's try to get it again. So, is this any different to what I have here? Oh, not here, but to the one that I had before for for the DFS. Okay. No, it doesn't hold. Okay, whatever. Let's check what have. Maybe I can find something nice here. DFS, DFS, tech. Okay, that was what was I looking for? So like BFS solution for this problem. Hmm. So like have some kind of level for the every node. Yeah, that works. Okay, let me finish my implementation here. Oh, I didn't save it. That's too bad. Okay, that's one. 3 node. And then let's say we have a pair. Let's say we have another queue. Say level. Mm, Let me see. So if I push the level here, how this will help me? I assume it won't help me. What will really help me is not level, but like the sum, partial sum. Queue not empty. I'll do this. Three node equals queue dot poll, and then let's say integer partial sum gonna be p sum gonna be partial ps, let's say ps partial sum dot poll And then what I'll do uh, uh, say if node left equals null. Let's say it's not equal null. Say if, then I'm gonna do the not queue that offer not that left, then ps multiplied by 10 plus not that wall. If not that right not equal null, I'm gonna queue offer not not left, and then psum offer this one. It'll offer not that right, and then the same ps if not that left equals null and not that right equals null, I need to let's say a sum plus equal ps multiplied by 10 plus not that wall. Mm. Mm -mm -mm. And then here I need to continue. Mm. Partial sum here. Okay, if I gonna go the queue deck, say push, then pop, and then here push, push. Mm. Mm. That's not even close. Yeah, because array deck is not that efficient here. It's better linked list. Better to have linked list, like double linked list, because array deck will spend some time on resizing the array and shifting it and moving stuff, and linked list is better here for the queue. It's interesting if I can do the Java save reference to object as int in Java. Can I do that? not what I want. Cost rate. Okay. Okay. Oh, this one is Ubuntu. That's nice.
Okay, so this in Java. Here's the first step in setting up a structure like this, and that is to begin by setting up an object that can
Can
contain
I
a
access the
single
row
item
pointer
in a
in
stack.
Java? I guess
Right, so
no.
this is a very simple class called a
Mm-hmm. So I was thinking about deck with, let's say we have Q, Q, back to the Q. So the maximum they're gonna be 10 elements. So meaning it's gonna be 2 to the power of 10. 2 to the power of 10. Okay. What does it mean? Can I have just integer? Like 3 node Q equals new 3 node. Let's say 2000. And then here integer. Let's say int. And then what I'll do, I'll have the left LQ equals 0, RQ equals 0, and then int LPS 0, int RPS equals 0. And then q dot lq plus plus equal root, and then rq plus plus, and then the same partial sum LPS plus plus, and then equals 0, and then RPS plus plus, and then while LQ less than RQ, do not equals Q LQ plus plus, and then partial sum L LPS plus plus, and then push. So for the push, I'm gonna do the following. I'm gonna do partial sum of Q RQ plus plus equals node that left, and then partial sum the same. RPS plus plus equals this expression. I do that quite a lot, so let's do that int val equals this one. as well. Here, val, and then uh, does it mean that I made a mistake here? What? What? Hmm. Hmm. Okay. Okay. That still needs to be here. That's a flaw. Let's adjust a little bit. Yeah, but still memory is not that good. How I can make it even better here? But I don't like this partial sum. Can I reuse the tree node here value? If I gonna reuse the tree node value, can I override it? Yeah, I'm gonna probably wrap up. There was a little bit experiments here and there. Yeah, I'm gonna wrap up. So general feedback, I guess pass, because I managed to solve it with DFS within like first 10 minutes of the video. Then I tried BFS, and actually I failed to code it like correctly. I looked up the solution, managed to re-implement it again, and then I also tried to optimize it a little bit. But as you might see, the optimization is still like overusing the memory. But generally speaking, it's hard to say whatever like here, like 0 milliseconds, and if it's better than like whatever BFS I had before, like this one, or like based on the like this 1 millisecond. It was 26% memory here for the BFS based on the queues, linked lists. So 23. So it was what for the memory? It was 41.41 megs, and here it's like also 41. Not that better. Yeah, I'll wrap up. That's all for today.